Welcome to the Fuel Pulse Show podcast, where we talk about all things fuel for all kinds of people. I'm your host, Eric Bjornstad, and I will be your guide through the ever-changing world of fuel. Now, at this podcast, we talk about all the things surrounding all the different kinds of fuel that we use on the job and at home. And we also talk about lots of things concerning the stuff that use that fuel, again, whether that's at work or at home, which means the Fuel Pulse Show podcast is really meant to be for everyone. So what are we going to talk about on today's episode? Well, we're recording this sometime in July, and since we happen to be based in Florida, we're kind of used to hot weather down here. But it seems like it's just getting hotter and hotter in more and more places around the country. And the thing is, as fuel professionals, we know that heat is one of the things that really does cause bad things to happen in stored fuel. But it's not something that many other people really think about, which means if we're going to expect the weather to continue to be hot over the coming months, it might be worth our while to start considering about the different ways that the heat affects our fuel. Then consider if that really puts us in a position where we might need to take some steps to prevent or head off some of those anticipated problems. So with all that in mind, let's get started on our discussion of heading off hot weather fuel problems. First, we want to start off with considering how hot is it supposed to get this summer, and is that significant or not? Now, there's both a narrative and a counter-narrative going that those have been developing for more than a decade concerning the whole topics of global warming and climate change. We've been hearing about how last year, 2023, was supposedly the hottest year on record. Now, this particular thing isn't just based on feelings or anecdotes. Scientific measurements globally really do support this claim. According to the World Meteorological Association, the global surface average temperatures have been consistently rising over the years, with recent years being the ones that top that historical chart. So you say that, and then there's the counter narrative that spreads in places like social media, where you have memes going around showing the temperature seen during a heat wave in June in the 1930s, implying that since it's happened before, what we're experiencing now isn't unprecedented or is being blown out of proportion. However, for this kind of issue, it really is crucial to understand the difference in scale and context here when we're talking about temperatures. See, the 1930s did experience some severe heat waves, and part of it was because here in the United States we had that whole Dust Bowl phenomenon, which really contributed to some major climate anomalies or climate changes. And that really did have an ill effect on the climate around the country, not just in Oklahoma and those places where the Dust Bowl was more concentrated, if you will. Yet, the frequency and the intensity and the global spread of heat waves that we're seeing today are largely driven by an ongoing increase in global temperatures. And that's a trend that really correlates with those increased greenhouse gas emissions over the last 100-something years, post-industrial revolution. There have been numerous studies that have shown that the last 8 years, not 80, but 8 years of our history have been the warmest years since modern record keeping began. And the thing is, if that kind of thing really is related to climate change, then you're not going to prove or disprove it by citing a small subset of data like temperatures that you observe over a single day. Like the Facebook meme that went around at the end of June, citing how California on the same day back in 1970 or 1930 or whatever year it was, how California on that same day reached 119 degrees. Okay? They put that out there to say, see, it was hot back then, no big deal. But climate change is a broader phenomenon. And if things really are getting hotter, then you're going to want to look at larger data sets over longer periods of time. So even if we go back before 2023, there's plenty of evidence to show how different parts of the country have been breaking heat records. Let's go back to 2021, the Pacific Northwest. Now, this region experienced at that time. There was a historic heat wave going on. At the time, it was referred to as a heat dome. And so you had cities like Portland, Oregon, and Seattle, Washington that really smashed their previous temperature records. Portland reached an all-time high in 2021 of 116 degrees. And then Seattle set a new record for them at 108 degrees. Okay, now, when you first hear that, Portland, Oregon's not supposed to be at 116 degrees, and yet it did in the heat dome of 2021. And those areas in the Pacific Northwest, they didn't just set single day records. They also set records for something else that we're going to touch on a little bit more later, and that is records for sustained heat over multiple days. And that's notable because, again, if you think about it, this is the Pacific Northwest we're talking about. We're not talking about Death Valley here. It's supposed to be relatively cool up there in Portland, Oregon, and Seattle, Washington. It's not supposed to be hitting 108 degrees or 116 degrees. In 2020, look at many parts of the Southwest, particularly Arizona and Nevada. States like Arizona and Nevada regularly do experience sustained high temperatures in the summer. We already know that. We expect that for them, and yet they really did in 2020. Phoenix, Arizona. If you live in Phoenix, you know that it's not that unusual for it to hit 110 degrees, and it's not unusual for Phoenix to hit 110 degrees on, consecutive days. But in 2020, Phoenix endured 53 consecutive days with temperatures over 110 degrees, which was their record by a long shot. Let that sink in for a moment. 53 consecutive days where every single day the temperature exceeded 110 degrees. That's pretty unusual. Go over to California in 2020 and 2021. California saw several severe heat waves that really included prolonged periods of extreme heat. In August of 2020, Death Valley, which off the top of my head, I can't remember if Death Valley's Nevada or California, but it's pretty close, so just roll with me here. In August 2020, Death Valley hit 130 degrees Fahrenheit, one of the highest temperatures ever recorded on the face of the earth. Now, let's fast forward from 2020 and 2021. Let's go to 2023, last year. We saw a bunch of places shatter their respective heat records. August 2023, it almost seemed like every day we were hearing about a new place that was breaking a record, and it was all across the country. I remember there was a particular day in August of 2023 that saw more than 200 places in the United States set their own particular records for what they call long period high temperatures. Long period high temperatures is a little bit different than just looking at high temperatures. What it is, it's the measure of a sustained period of hot weather for an extended period of time. Specifically, if you're having a long period high temperature, then during that period, the temperature has to consistently stay above the average temperature for that specific location and time. It's different than just saying Phoenix, Arizona set their record of 16 degrees. It's very different than that. It's a measure of it being way too hot for as long a period of time as possible, if you want to put it that way. So think about that. More than 200 places in the United States didn't just set their high temperature records. They set their records for it being hotter for longer than at any point in their particular histories. More than 200 places. If we think about that, this isn't the Facebook meme bragging about how climate change isn't real because on June 26, one particular place back in 1930 reached 119 degrees. This is way more than that. This is more than 200 places of measurement across the country that set records, not just for high heat, but for sustained high temperature over a record long period of days. 200 places in the country setting records in one day. If it helps, we could name some specifics. On August 23rd, Austin, Texas was working on a streak of 44 consecutive days over 100 degrees Fahrenheit, and they didn't end up ending that streak till into the month of September that year. Big Bend National Park reaches 119 degrees. That's in Texas. Death Valley, remember we said they hit 130 degrees in 2020. Well, in 2023, They didn't reach 130, they reached 128 degrees, just 2 degrees short of that record for them. The individual list of cities that broke these records, it's just too long to list off. And it's kind of, once you've heard the 100th city name, it doesn't resonate. Once you've heard 100, you've heard 200, right? Point is, temperatures everywhere and in every part of the United States, the evidence seems to show that those temperatures are getting hotter. How exactly are they so sure that it really is getting hotter? If we're looking at the question of whether that's related to the climate changing, contrary to what the arguers on social media seem to be so sure of, if the scientists want to raise their hands and say, hey, this day was the hottest day on planet Earth in recorded history, you can be sure that those folks are not just saying that because they looked at a couple of mercury thermometers at different ends of the country. Documenting extended heat in a location typically involves looking at a bunch of different things. So, what do they look at? To be fair, of course, one of the things they do look at is maximum temperature records. And why wouldn't they? That is something that does tell us something meaningful. Tracking the highest temperatures recorded each day, comparing them to historical averages and records. They start by doing that, but then they also look at that consecutive days above threshold, the one that we mentioned earlier. And this one's actually really important for documenting sustained heat if you didn't already know that. And it makes sense that you'd want to look at, because if you were trying to get a true picture, an objectively true picture of whether the climate was changing in a significant way, you would look at something like that. Consecutive days above threshold involves counting the number of consecutive days that the temperature surpasses a significant threshold. And you can pick which threshold that is. If it's 90 degrees, if it's 100 degrees, maybe it's higher. So they will look at that in addition to looking at the maximum temperature records and how those compare to typical years. Then they will also look at something else. They will also look at the nighttime temperatures along with not the high maximum temperatures, but the high minimum temperatures, especially the overnight lows. If it's a situation where they're not dropping significantly, that can actually be something really important to look at. Because if you think about it, the nighttime temperatures and the high minimum temperatures, those aren't just important from an academic exercise standpoint. They're important for practical public health purposes, because cooler nighttime temperatures typically provide relief from the daytime heat. It's always hot in the daytime, right? But then at night, it's supposed to cool down. It's supposed to give both people and animals and the environment, supposed to give them relief. That's the way that cycle is naturally supposed to work. But if those cooler nighttime temperatures aren't actually that much cooler, then you don't get that benefit. And that is a problem. The point is, assessing and concluding how hot it is now involves looking at more than just seemingly simplistic stuff like what's the high temperature. But remember too, part of what's being talked about here is this idea that not only is it hot right now, we already know that, but part of what's being talked about is the idea that the hot weather that we're going through now, some people say it's a historical anomaly. This is the hottest day on record. It's a historical anomaly in that sense. So you've got that, and then you've got the counter narrative going where these other folks are saying, no, they don't know what they're talking about. What we're seeing is just a relative blip on the historical radar. It's just part of this long-term natural temperature ebb and flow that goes from high to low. It's normal to do that. There's nothing significant to see here, and it certainly isn't affected by anything that we humans do, right? So you've got those two things competing against each other, right? Back in July of 2023, specifically July 2nd and July 3rd, they made this announcement. They said that July 2nd and July 3rd, 2023 were officially the two hottest days on planet Earth in the last 100,000 years. Wow, that is a big claim. And because it is such a big claim, that claim was met with a lot of skepticism. people naturally were asking, how can they possibly know that? Well, let's key in on that and zoom in on a little bit. It's one thing to talk about the temperature, how it compares to 100,000 years ago. They haven't been keeping those records for 100,000 years, but they have been keeping actual temperature records for the last 175 years or so, which means they can at least say that July 2nd and July 3rd were the two hottest days in the last 175 years. They can say that with pretty clear certainty. But that's a different and seemingly less significant claim than the broader one that they made just a minute ago, which was that we had days in July 2023 that weren't the hottest in 175 years, or not just the hottest in 175 years. They were the hottest in the last 100,000 years. That's a much bigger claim. And a lot of people didn't believe them. If we're going to entertain that idea, we have to at least be willing to acknowledge the possibility that they're not just making things up there. They have a reason for making such a seemingly huge claim as that. And the reason is because they have, or they think they have, broader evidence that it is actually likely to be true. Well, how do they know that? I mean, how can they possibly know that? Nobody was around taking the Earth's temperature when the Roman Empire was around, or when the Neanderthals were killing the woolly mammoths. How can they possibly know that? Scientists do have some good tools at their disposal that they can use to estimate what the temperatures were for many thousands of years ago. And it all comes from a field of study called paleoclimatology. The methods that are derived out of this field can help us understand what the Earth's climate may have looked like such a long time ago, and then look at how it might have changed over long periods of time since then. What are the kinds of things that they look at? One of the things they can look at are ice core samples. Those are samples taken from inside ice sheets and glaciers around the world. And this matters because the ice that's inside those sheets and inside those glaciers is actually really old, like many thousands of years old. For example, if they go to Greenland, a lot of ice up there, right? There's a big ice sheet covering just about the entire country of Greenland. So they go up to Greenland, they take an ice core sample, which is like an apple core, if you will. They take a thing and they stick it down and they pull up a long tube of ice that gets ice not just from the surface, but some amount down below the surface, right? If they do that, some of the ice that they're going to get could be as old as 110,000 years old. That's pretty old. Better yet, go to Antarctica, where the ice there, again, taken from an ice core sample deeper than the surface, the ice in Antarctica below the surface can be more than 800,000 years old. So these ice core samples are pretty old. But why does that matter? It's just ice. Well, it just so happens that these layers of ice down there, they actually contain tiny little air bubbles. You can see if you make ice cubes, right? Look at your ice cubes, you'll see tiny little air bubbles. Anytime you have ice that's freezing, you get air from the atmosphere at the time that gets trapped in that ice. And that's what's happened here. So they pulled an ice sample up that, let's say they think it's 100,000 years old. Well, that means that the air in that sample is 100,000 years old. And then what they will do is they will analyze the composition of those air bubbles. And what they're looking for is they're looking specifically at isotopes of molecular oxygen and molecular hydrogen that's in the air in those ice. And depending on what they see with that, scientists can actually make some pretty decent inferences about what the temperature was like 100,000 years ago, right? So, ice core samples is one thing. They can look at something more recent, like tree rings. So before you scoff at that, think about this. Trees, right? They grow one ring each year. That's natural phenomena. The thickness of those rings tells us something about the conditions that the tree experienced during that given year, including tells us something about temperature. If you have a wider, a thicker ring, that indicates that the climate for that time was warmer and more favorable to the tree's growth. So it grew more, made a thicker ring. And then the converse, if the ring is narrower, that means that the temperature might have been cooler, the climate might have been harsher during that year that produced that ring. And so what scientists will do, they'll look at tree rings from around the world, and they can get a sense of the climate's temperature during the tree's life by looking at those rings. Now, there is at least one thing we have to keep in mind here, because we were just talking about ice core samples had been hundreds of thousands of years old. We know that tree rings don't go back 100,000 years. They're only applicable to the climate when the tree was alive. So tree rings aren't necessarily going to give us a clue about climate temperatures from 10 or 20 or 50,000 years ago, unless it's a fossilized tree ring, but that's another story. However, tree rings are part of the picture we can use. And then similarly, there's another thing that they can look at on the aquatic side, and that is they can actually look at what's going on with coral reefs. So coral reefs are a little bit like trees in the sense that they grow in layers. Each layer forms over a given year. And so similar to what they do with tree rings, they can look at the thickness, but also the chemical makeup of those coral layers. And they can get insights into the ocean temperatures and the subsequent climate conditions. Again, another relatively short-term method similar to the tree rings, but again, completely different from just looking at surface air temperatures. Okay, so tree rings and coral reefs are kind of the short-term things. We already mentioned core ice or ice core samples as being kind of a long-term thing. And they can also do a similar thing with sediment core samples from lakes and from oceans, because we know that lakes and oceans accumulate sediment over time, and that sediment will contain a lot of different things, but it will contain among them, it'll contain tiny organisms, and it'll contain a bunch of other types of materials. So they can take a sediment core sample in much the same way that they take an ice core sample, and then they'll analyze the types of organisms and the chemical composition of the sediments. And depending on what they find, they can make some valid inferences about past climate conditions from that. And then one of the final things that they can look at is what they call isotope analysis, because there are certain isotopes of elements like oxygen and carbon. And we know that those specific isotopes actually behave differently in different temperatures. What scientists will do is they'll take a sample and they'll look at the ratio of the isotopes in certain kinds of materials like shells and also sediments that we just talked about. And by doing that, they can draw some inferences with respect to past temperatures. When scientists make claims about certain days being the hottest on record, they do that because they have compiled over many years and through the efforts of thousands upon thousands of scientists and professionals from all parts of the globe, they've compiled a body of evidence going back many thousands of years, not just the past 175 years. This isn't a situation where they're just making stuff up to sound good. They do have a reason for making the claims that they're making. So, with that, we're going to stop with part one of our discussion here, because in part two, we're going to conclude our discussion by talking about how hot it is and why they think it's historically hot. Now we want to take that acknowledgement, we want to apply it to our fuel. We want to talk about some more specific things on the actual problems that this heat contributes to with our stored fuel, and then the best practice recommendations for heading those problems off. So we hope that you'll join us for that discussion. In the meantime, feel free to subscribe to the podcast. And if you will, please leave us a rating at iTunes or Stitcher, wherever you like to listen to your podcast. We really appreciate that. So until next time, thank you for joining us. And we'll see you next time for the next episode of the Fuel Pulse Show podcast.